Welcome back. Today we're going to be talking about exploring independent versus dependent events where we're talking about probability. Let's get started. Okay, a few things to remember before we get started. We're going to be looking at compound events, and we're going to compare the probability with replacement and without replacement. And remember that when we talk about with replacement, we're talking about independent events, and when we talk about without replacement, we're then talking about dependent events. This is important to know as we go ahead moving forward. So let's take a look at our first situation. And our first situation says Liam will pick 2 marbles. What is the probability they will pick a striped marble and then a white marble? And on the first side, we're going to be talking about with replacement. And on the other side, we're going to be talking about without replacement. And we're trying to figure out which one has the greater probability. So let's take a look at with replacement first. So first he's going to pick a striped marble and then a white marble. So we've got 1 striped marble out of the 6 marbles that are there, and 3 striped marbles out of the ones that are there. So the first time he's going to reach in, he's going to get 1 out of 6 chances for that. The second time he reaches in, since he's putting the marble back, we're still going to have 6 marbles in there. So that time there's going to be 3 striped marbles, so 3 out of 6. So when I put that down, I've got 3 out of the 6 are striped, 1 out of the 6 is white, 3 times 1 is 3, 6 times 6 is 36, and then I can reduce my fraction because remember I want it in simplest form, so my fraction reduces to 1/12. I'm also going to write my probability as a decimal because it's a lot easier to compare decimals than it is to compare fractions. So I'm going to convert my fraction into a decimal, dividing the top by the bottom, or dividing the numerator by the denominator. And when I do this, I end up getting 0.083 repeating. So that's the probability for with replacement. Now let's do it without replacement. So again, he's going to reach in, he's going to grab a striped marble, he's going to then set it aside because we're doing it without replacing it, and then he's going to reach in for the white marble. So the first time he reaches in, again, there'll be 3 striped marbles, so 3 out of 6, and then he'll go back and reach for the white marble. However, when he goes for the white marble, he'll have removed one of the striped marbles, leaving only 5 marbles remaining. So the first time he reaches in, he's got a 3 out of 6 chance. But then he's going to reach in and find only 1 out of 5. Our total number of marbles has changed because he's taken one of the marbles out and he's put it aside or in his pocket. So we've got 3 times 1 is 3. 6 times 5 is 30. I can reduce that fraction. 3 out of 30 is 1/10. So I'm going to put that down as my fraction, 1/10. And then I'm going to turn that into a decimal, dividing my numerator by my denominator, or my top by my bottom. And when I do that, I get 0.1. So then it asks, which one is the greater probability? And in this case, the greater probability is without replacement. And we can see that because we see that 0.1 is greater than 0.083. The 1 is going to be more than the 0. So we know that without replacement, or in this case, dependent probability, is greater than with replacement or independent probability. Let's take a look at the second situation. So here we are at the second situation, and it says Whitney will pick 2 cards from the set below. What is the probability she will pick a circle and then a heart? And again, we're going to do this with replacement and then without replacement. So we're taking a look at our first scenario. She's going to pick a circle, and we can see there are 4 circles out of 9. Then again, she's going to put that card back and then select a heart, and we can see there are 3 out of 9. So for our first scenario, we've got 4 circles out of 9 times 3 out of 9. 4 times 3 is 12. 9 times 9 is 81. And we're going to reduce our fraction, which is going to give us 4/27. But again, since we're going to be comparing probabilities, it's a lot easier to compare probabilities using a decimal. So I'm going to divide my numerator by my denominator. When I do that, I get 0.148 repeating as my decimal. Now let's try it without replacement. So in this case, I'm going to begin looking at the circles. So go in with the circles. Again, 4 out of 9, no problem. But then we're going to take that card and we're going to set it aside somewhere. So now we no longer have 9 cards, we only have 8. So when she goes back for a heart, she's got 3 out of the 8. So we've got 4 times 9, 4 ninths times 3 eighths. 4 times 3 is 12. 9 times 8 is 72. 12 70-seconds is going to get reduced to 1/6, so that's our fraction. And again, we want to compare using decimals, so we're going to convert our fraction to a decimal. When we do that, we get 0.16 repeating. So it says, which has the greater probability? We're going to compare them. The ones are the same. However, the 6 is greater than the 4, so therefore we know that without replacement or dependent probability is the one that is greater. Now let's take a look at why that may be. So taking a look at summary number 1, it says in situation number 1 and 2, which had the greater probability with replacement or without? And as we know, both times we got without replacement. So the question is, why do you think this is? And the real reason is because we ended up reducing the total number of outcomes in the second scenario. So when we removed something, it was a lot easier to get the things that we wanted because we left all of the favorable outcomes in and we took out a larger outcome that is not one that we would want. So when we do that, that increases our probability. So we reduce the total number of outcomes, but not the number of favorable outcomes. So the favorable outcomes stayed the same, but the total number of outcomes changed. And since our favorable odds went up, when we took out the thing that we didn't want, obviously that's going to give without replacement a much better chance. Now let's take a look at another couple of scenarios and see if it turns out to be the same thing. So here we are at situation 3, and it says Ross will pick 2 marbles. What is the probability that they are both black? So again, we're back to our bag of marbles, except this time we're going to be drawing 2 marbles of the same color each time, and we're going to do it with replacement and then without. So the first time that we reach in for the black marbles here with replacement, we've got 2 out of the 6 marbles are black, so we're going to have 2 out of 6. And then we're going to replace them back in. We still got 2 black marbles. We still have 6 marbles. So we're going to have 2 6 each time. We've got 2 6 and 2 6. 2 times 2 is 4. 6 times 6 is 36. That's going to reduce to 1/9. So I'm going to write that as my fraction, 1/9. But again, I'm going to be comparing probabilities. It's a lot easier to do that as a decimal. So 1/9 converted to a decimal is 0.1 repeating. Now let's try it without replacement. So the first time we go in, we got there 2 black marbles out of 6, so 2 6. However, the second time that we go in, we need to remove a marble in total, so our total marbles is going to drop from 6 to 5. However, since we took out a black marble already, we only have 1 black marble remaining. So therefore, our first fraction is 2 out of 6, but our second fraction is 1 out of 5. Why is it 5? Because we reduced the total number of marbles from 6 to 5 by removing 1 and not replacing it. And why did the 2 drop to 1? Because again, the first time we're assuming that we picked out a black marble and we want to go back in for the second black marble. Since I already removed 1 and I'm not replacing it, the total number of black marbles dropped from 2 to 1. So now we're going to multiply. 2 times 1 is 2. 6 times 5 is 30. So I got 2/30. That reduces to 1/15. And there I go, 1/15 is my fraction. I'm going to turn that to a decimal, and I'm going to get 0.06 repeating. I'm going to compare them for which one is greater. And in this case, the 1 is greater than the 0. So in this case, my greater probability is with replacement or independent. Let's take a look at another situation. So here we are at situation 4, and it says Tipyan will pick 2 cards from the set below. What is the probability that she will pick 2 hearts? So looking at with replacement and without replacement. So again, we're going to be going for the same card. So the first time there are 3 hearts out of 9, and we're going to put that card back, so there'll still be 3 cards out of 9. So for our first scenario, we've got 3/9 times 3/9. So 3 times 3 is 9, 9 times 9 is 81. 9 over 81 reduces to 1/9. So we've got our fraction as 1/9, but again, we're going to be using decimals to compare because that's a lot easier. So 1/9 converts to 0.1 repeating. So now we're going to do it without replacement. So again, she's going to go in the first time. There's 3 hearts. There's 9 cards, so we've got 3 out of 9. But the second time she goes in, we've reduced the total number of cards. So she took one of her heart cards and then she put it in her pocket. So there are only 8 cards remaining total, and she took one of the cards that are hearts. And we're looking for heart cards. However, instead of 3, now there's only 2. So this time we've got 3/9 because there were 3 hearts the first time, 9 cards the first time. Then she put one in her pocket. We've got 2 cards left that are hearts and 8 cards total. So we're going to multiply. 3 times 2 is 6. 9 times 8 is 72. 6/72 reduces to 1/12. So we're going to have our fraction as 1/12. And again, we're going to use decimals to compare, and 1/12 as a decimal is 0.083 repeating. So which one is greater? The 1 is greater than the 0. So we know that with replacement or independent probability is the greater probability here. Now, let's summarize why we think it turned out this way. So here we've reached summary number 2, and it says in situation number 3 and 4, which has the greater probability with replacement or without? Why do we think this is, and how is it different from summary number 1? So I want you to try and think about these answers for yourself. When you think you've got it, go ahead and check it with your teacher, and you will have completed these set of notes. Now, this reaches the end of this video, so if you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one.